Hi viewers, how are you all? In the previous session we have discussed regarding the types of physical quantities, vectors and unit vectors, and in this session we are going to learn about the addition of vectors, in which we have the laws of vector algebra. Then why late? This is SANTHOSH Kumar. Welcome to my channel Sims Academy. Basically, how many laws of vector addition are there? We have two. One is triangular law of vectors and the second one is parallelogram law of vector addition. Okay, wait. We have even polygon law of vector addition for more than two vectors if we do have. Okay, first let us move on to the triangular law of vectors. What does this triangular law of vectors say? If I have any two vectors, let us say this as A bar and this as B bar. If two vectors acting on the same particle, if in both magnitude and direction taken in the same order, continuation, then their resultant is given by the third side of the triangle, both in magnitude and direction in the opposite order. You see here we have taken, okay, let me draw again. As I already told you, I cannot draw well, I am not a good artist. Okay. This is a vector A, this is a vector B, okay, this is A bar, this is B bar, and its resultant, it is taken in the opposite order. Okay, let us move in another manner. This is B bar, this is A bar, then the resultant, there is no difference in the resultant here. R bar. This is about the triangular law of vectors. If two vectors acting on the same particle, the same time with different magnitudes and directions, taken as the two sides of the triangle in the same order, then the resultant is given by the third side, both in magnitude and direction taken in the opposite order. Here we can write its magnitude R bar equals to A bar plus B bar. This is the triangular law of vectors. Then what about the polygonal law of vectors? Sorry, not polygonal. Parallelogram law of vectors. Parallelogram law of vectors. What is the difference between these two vectors? If suppose two vectors, I like P bar, two vectors which are starting from the same point, which are acting on the same particle at the same point, represents two adjacent sides of a parallelogram. If these two acting on the same particle in magnitude and direction represents the two adjacent sides of a parallelogram, then the diagonal represents their resultant. R bar equals to P bar plus Q bar. Let us suppose the angle between those two vectors, angle between P bar and Q bar, angle between P bar and Q bar be theta. Let us say, then let alpha be the angle made by P bar with resultant or resultant with P bar. That means the angle between these two is alpha. Then what about the magnitude of resultant? We have the derivation in our IPE. I am directly writing the formula. The resultant R equals to under root of modulus of R. Its magnitude is given by under root of P square plus Q square plus 2 modulus of P into modulus of Q into cos theta. What is mod Q, mod P, mod P, mod Q, modulus of R? They do represents the magnitudes of the vectors P, Q and R respectively. Okay? Now, what are the special cases? Special cases we have to see here. Now, if theta equals to 0 degrees, that means that they are parallel vectors. If theta equals to 0 degrees, then what is cos 0 value? Cos 0 value is 1. Then we get modulus of R equals to under root of P square plus Q square plus 2 mod P into mod Q, where cos theta is 1. It is of the form in our 6th class only. We have learned this: a square plus b square plus 2ab. It is a plus b whole square, that is under root of mod p plus mod q whole square, and root gets cancelled. Now it becomes mod p plus mod q, which is the maximum value. When the two vectors are parallel, then the resultant is maximum. What happens if the angle between them is theta equals to 180 degrees? If theta is 180, implies cos 180 degrees equals to minus 1. 180 trigonometry, 180 minus theta lies in second quadrant. In second quadrant, cos is negative. For 180 degrees angle, cos remains as cos. Hence we get minus cos 0, minus 1. Then what do we get? Mod R equals to under root of mod P whole square plus Q whole square plus 2 mod P into mod Q into minus 1. That is nothing but P square Q square minus 2pq, again a square plus b square minus 2ab. It becomes our a minus b whole square. That is under root of mod p minus mod q whole square. Square and root gets cancelled. We are left with mod p minus mod q. Modulus of p minus modulus of q, which is the minimum value. We have seen the two special cases. That means when theta is 0 degrees, cos theta is 1, and the resultant value is maximum, that is modulus of p plus modulus of q. When theta is 180 degrees, I said when theta equals to 0, the two vectors are parallel to each other. If theta equals to 180 degrees, then they are anti-parallel. Of course they are parallel, but they are moving in the opposite direction. Here we say them as anti-parallel. When theta equals to 0 degrees, we say the vectors are parallel. When theta is 180 degrees, then we say the vectors are anti-parallel. When theta is 0 degrees, then we get the resultant as the maximum value, that is mod R equals to mod P plus mod Q. If theta equals to 180 degrees, then the resultant is minimum, that is mod P minus mod Q. And the third important case we have to keep in our mind is no two vectors No two vectors with unequal magnitude will have the resultant 0. I'll mention this is the case 1, this is the case 2, and case 3 I shall mention here. No two unequal vectors will have, okay, not grammatical errors, will have their resultant as 0. If they are equal vectors, we may be having the chance P, Q are equal vectors. Then what happens whenever they are anti-parallel? The resultant becomes 0. But if they are unequal vectors, then the resultant is never 0. Now we came to understand that the magnitude of the resultant of any vector, two vectors we have considered, P bar and Q bar, their resultant is given by, magnitude of the resultant is given by under root of P square plus, for our convenience I am not using the modulus, under root of P square plus Q square plus 2PQ cos theta, where theta is the angle between the two vectors P bar and Q bar. Okay? And it becomes maximum when the two vectors are parallel, and it becomes minimum when the two vectors are anti-parallel. And the third case we have discussed is no two vectors with unequal magnitude will have the resultant as 0. Okay, we got the magnitude of the resultant. Then what about the direction of resultant? If this P bar makes an angle theta, if this P bar makes an angle alpha with R bar, or the resultant makes an angle alpha with P bar, then the resultant direction is given by tan alpha equals to Q sine theta by P plus Q cos theta. Q sine theta by P plus Q cos theta. Okay? And suppose instead of this one, if R bar makes an angle beta with the resultant, then we get the angle of resultant is given by tan beta equals to reverse of that P sine theta by Q plus P cos theta. Any of these two we can use for better understanding and not getting confused. We use only one whenever it makes an angle alpha with P bar. Even we could take if it makes beta with Q bar. Okay. Now let us jump into our numericals. Okay. Now let us move on to the numerical. Here already we discussed 5 numericals in the previous class. The sixth one, if the ratio of magnitudes of two forces is 5:3 and the magnitude of their resultant is 28 newtons, then find the magnitude of each force. This is the question we are being asked. Okay, now before solving, let us recall our parallelogram law of vectors. Their resultant is given by under root of p square plus q square plus 2pq cos theta. Okay, let the angle between them be 60 degrees. It is given. Now, as we are given P is to Q equals to 5 is to 3, I can write them as P equals to 5x, Q equals to 3x, and resultant it is given as 28 newtons. Angle of inclination theta equals to 60 degrees, which implies cos 60 equals to 1 by 2. Now let us go on to the formula. 28 equals to under root of p square 5x whole square plus q square 3x whole square 2 into 5x into 3x into cos 60. How much is the cos 60 value? Okay, we shall write in next step. 28 equals to under root of 25x square plus 9x square plus it is 2 into 5 3 15x square into 1 by 2. 2 gets cancelled. Now we are left with 28 equals to under root of this is 25x square plus 9 plus 15. Let us write them. 25x square plus 9x square plus 15x square. 25 plus 15 it is 40. 40 plus 9 49. 28 equals to root 49x square. Square root of 49 it is 7. Square root of x square x. 7x equals to 28. X equals to 28 by 7. 7 fours. We got the value of x. Then what is the value of p? P is 5x. 5 into 4 it is 20 newtons. Q is 4x. 4 into 4 equals to 16 newtons. Now we got the magnitude of each force. What if he asks us to find the resultant? The direction of resultant. How should we find the direction of resultant? As I told you, he did not mention. Okay, we can write tan alpha equals to q sin theta by p plus q cos theta. You please substitute that is q. What is q value? 16 into sin theta is root 3 by 2 by p again 20 plus q again 16 into cos theta, it is 1 by 2. 2 ones, 2 8 times. It is 2 ones, 2 8 again. It becomes 8 root 3 by 20 plus 8, 28, 4 2s, 4 7s. That is, we got tan alpha value equals to 2 root 3 by 7 implies alpha equals to tan inverse of 2 root 3 by 7. This is the direction of resultant if he asks us. This is the direction of resultant. You see, we are given the ratio of the magnitudes of the two vectors, and even the resultant magnitude is given as 28 newtons, and the angle between the two vectors is 60 degrees. We applied the parallelogram law of vectors, where the resultant magnitude is r equals to under root of p square plus q square plus 2pq cos theta, where theta is the angle between those two vectors. You found the value of both p and q here after finding the value of x. And again, if he asks us to find the direction of resultant, then we have to substitute. And this is the angle made by the resultant with p or q. That is very important. This is alpha is the angle made by the resultant with the vector p bar. Okay, now let us move on to another problem. Let us move on to another problem. Right. A body displaces 4 meters towards east and 3 meters towards south. Find the magnitude and direction of resultant. Find the magnitude and direction of resultant. Okay, we shall take the Cartesian coordinate axis from where the object has started from O. Let us suppose it has traveled 4 meters towards east. This is east, west, north, south. Yes? In our social studies, we draw like this only. Now, it has displaced 4 meters towards east and 3 meters towards south. We have to find the resultant. Then what are we supposed to apply here? We apply the triangular law of vectors. The resultant is given by this one. What is the magnitude of that resultant? R equals to under root of, because we have the angle between them is 90 degrees. If the angle between them is 90 degrees, then we can apply Pythagoras theorem even directly over here. Under root of 4 square plus 3 square, R equals to under root of 16 plus 9, 25, that is 5 meters. The magnitude of resultant is 5 meters. What is the direction of resultant? It went east, south. Then it becomes east, south, southeast. At what angle it's being displaced? At what angle it's being displaced? We need to find out. We can even apply cos or sine or tan, whatever we want. Okay, let us see. This is adjacent to theta and this is hypotenuse. If we apply cos theta, then it becomes, we get 4 by 5. Then theta equals to cos inverse of 4 by 5. That is, it is nothing but south east direction. This is about this problem. Okay, let us move on to the next numerical, that is our 8th one. Let us move on to the next one. Two equal vectors having same magnitude have their resultant equal to either of the two. Find the angle between them. Super problem. What is the thing that is given? Two equal vectors. In the sense, P bar equals to Q bar equals to having same magnitude. Okay, let us say both of them have their magnitude as A bar. Have their resultant equal to either of the two. In the sense, their resultant also equals to A. Okay, let us say it is a scalar value A. Now we are asked to find the angle between them. Let us move on to the parallelogram law of vectors. The resultant is given by under root of P square plus Q square plus 2PQ cos of the angle between them, that is theta. Now resultant A equals to under root of P is A, Q is A into A. And cos of the angle between them, what are we supposed to find? We should find the value of theta. Okay. Now let us square it on both sides. Then we get A square equals to A square plus A square, 2A square, again 2 into A, 2A square cos theta. Okay. Let us bring this A square to this side. Then we get A square minus 2A square equals to 2A square cos theta, or 2A square cos theta equals to, what is A square minus 2A square? Minus A square. Here A square gets cancelled. Now 2 cos theta equals to minus 1 by 2. 2 cos theta equals to minus 1. Cos theta equals to minus 1 by 2. Minus 1 by 2. In the second quadrant, for what value of theta? Okay, we shall write like this. Minus 1 by 2 in the sense cos theta equals to, this is the minus, this becomes cos 1 by 2 in the sense 60 degrees. Let us send this to this side. It becomes easier for us. Minus cos theta equals to cos 60. Okay. When do we get minus cos theta? Cos of 180 minus theta equals to cos theta. Cos 60 degrees. Now cos gets cancelled. 180 minus theta equals to 60 degrees. If I send the theta to that side, 60 to this side, then we get 180 minus 60 equals to theta, or theta equals to 120 degrees. Theta equals to 120 degrees. That means these two vectors are separated by an angle of 120, where the resultant is between them. This is 60, this is 60, this is R, this is P bar, this is Q bar. Here we came to understand, whenever two equal vectors are separated by an angle of 120 degrees, two vectors of equal magnitude, I am mentioning, are separated by an angle of 120 degrees, the resultant is also the same. What is same? The magnitude of resultant is same of either of the two vectors. Here we move on to the next problem. a truck moving due north at a speed of, let us say, 20 meters per second turns due west at the same speed. Find the magnitude and direction of the resultant. Okay. A truck traveling due north, the speed of 20 meters per second, takes due west, turns due west with the same speed, 20 meters per second. Okay, let us say it has V1, V2. If we write in terms of vectors here, V1 equals to, it is along the y-axis, then we get 20j. And V2, it is along the negative axis of x, then we get 20 into minus I, minus 20i. Now, what is the change in the velocity? Find the magnitude and direction of the resultant or change in the velocity. Now, we shall find the change in velocity first, that is V2 minus V1 minus 20i minus 20j. If I take minus 20 as common, then I am left with I plus j. Then what is the magnitude of that one? Delta V equals to, we know how to calculate the magnitudes, right? This is minus 20. Okay. Let us not make this one complicated. Under root of minus 20 whole square plus minus 20 whole square. How much is minus 20 whole square? It is 400. It is also 400. Under root of 2 into 400. 400 square root is 20 root 2 meters per second. That means the magnitude of change in velocity is 20 root 2 meters per second. Now, what is the direction of that? How can we find the direction? Yes, let us say this resultant has made an angle theta with the y-axis. An angle theta with the y-axis. Then I can write tan theta equals to opposite side by adjacent, 20 by 20. That is tan theta equals to 1. Theta equals to tan inverse of 1. That equals to 45 degrees. That means theta equals to 45 degrees in the sense it is north, it is west, it will be northwest. That means the change in velocity is 20 root 2 and the resultant is 20 root 2 meters per second in northwest direction. This is the sole problem. Okay? Yeah, now let us move on to the next problem. That is the 10th one. If modulus of p plus q equals to modulus of p minus q, then find the angle between P and Q. Find the angle between P and Q. Okay, now coming to the parallelogram law of vectors, if P plus Q are separated by theta, then we get their resultant as under root of P square plus Q square plus 2PQ cos theta, and P minus Q is under root of P square plus Q square minus 2PQ cos theta. Root gets cancelled on both the sides. We are left with P square plus Q square plus 2PQ cos theta equals to P square plus Q square minus 2PQ cos theta. P square, Q square gets cancelled. Now let us bring that minus 2PQ to this side. 2PQ cos theta plus 2PQ cos theta equals to 0. 4PQ cos theta equals to 0, or cos theta equals to 0. Then the angle between P and Q, angle between P and Q, cos theta 0 in the sense theta should be equals to 90 degrees. If P comma Q are separated by an angle of 90 degrees, then P plus Q is equals to P minus Q. This is the problem. Okay guys, today we have done with triangular law and parallelogram law of vectors and some numericals based on them, and the next we are going to learn about the resolution of vectors in the third part. Until then, I am signing off. This is Santhosh Kumar from Sims Academy. Take care. Bye bye.